Okay everyone, let us now have our first example. We have here y double prime minus 3y prime minus 4y is equal to 3e raised to 2x. Now, as you can see, our coefficients here are 1, negative 3, and negative 4. So those are all constants. Okay? And if we take a look at our right-hand side, we have here 3e raised to 2x, which is an exponential function. So the first thing that we need to do, again, is to find yc, right? Because the general solution of this non-homogeneous equation is y is equal to yc plus yp. Okay, so our goal first is to find yc. Okay, so let's start by finding the auxiliary equation. Okay, so auxiliary equation here is m squared minus 3m minus 4 is equal to 0, right? Oh wait, let's write first our associated homogeneous equation. So that is y double prime minus 3y prime minus 4y is equal to 0. And then we get our auxiliary equation. Okay, there we have it. Now, if we find the roots of this, what do we get? We will get m minus 4 and then multiplied by m plus 1, right? It's equal to 0. So applying the zero product property, we will get m minus 4 is equal to 0, m is equal to 4, and m plus 1 is equal to 0, m is equal to negative 1. Now, given these values of m, these are two distinct roots, right? So this is the case 1 of the auxiliary equation method. So our yc is equal to c1 e raised to 4x, right? And then plus c2 e raised to negative x. Okay, so if you forgot about this, you can review the video on the case 1 of the auxiliary equation method. Okay, so now that we have our yc, we can set it aside first. Okay, so now what we need to do is to find our yp. So let's copy our equation again so that we won't lose track of it. So let's copy it. Okay, so this is our original equation. So let's take a look at our g of x. So our g of x is an exponential function 3e raised to 2x. Now, the appropriate guess for this would be yp is equal to a, which is an arbitrary constant, e raised to 2x. Okay, so you might be wondering why is the general case e raised to 2x and not e raised to x? So you must be very careful about this because e raised to 2x and e raised to x are different functions. They are linearly independent. Okay, so this is the proper guess right here, e raised to 2x. Okay, so now that we have our informed guess for yp, we can then get our first derivative and second derivative, so we can substitute it to our original equation. So you get y prime of p is equal to 2a e raised to 2x. Y double prime of p is equal to 4a e raised to 2x, right? So we can then substitute. So y double prime is 4a e raised to 2x. Let's write that properly. So we have here 4a e raised to 2x, then minus 3 multiplied by 2a e raised to 2x. And then minus 4 multiplied by a e raised to 2x is equal to 3e raised to 2x. So let's simplify this. 4a e raised to 2x minus 6a e raised to 2x minus 4a e raised to 2x. Now, you can see here that both of these cancel out. We are left with negative 6a e raised to 2x equal to 3 e raised to 2x. Now, you cancel this out, and then we now have our value of a is equal to 3 over negative 6, or our a is negative 1/2. Okay, now we have our value for our a. Okay, we can then substitute it to our guess right here, yp. So yp is equal to negative 1/2 e raised to 2x. So this is now our particular solution. Okay. So now that we have our particular solution and our our complementary function yc, we can now get the final answer. The general solution of our non-homogeneous equation is y is equal to c1 e raised to 4x plus c2 e raised to negative x minus 1/2 e raised to 2x. Okay, so this is now our answer. Okay, so thank you for watching this video. I hope you learned something new, and we'll take a look at different cases in each example. So yeah, see you in the next video.